start recording. So, good morning everyone. My talk is Go Concurrency Constructs. It's a simple introduction to Go's concurrency paradigms, and my name is Gaurav Agarwal. I'm a lead technical consultant at Tarka Labs. I've been an ex-ThoughtWorker, ex-BrowserStackin. I've been an independent consultant for a while, and I've been running Go meetups for the past 6 months. So today's agenda is I'm going to walk you through a simple scraper, and then so I've already written the code for that, so we are not going to write a simple scraper code from scratch, but what we are going to focus on making the scraper concurrent using Go routines, then syncing them up with wait group, mutexes and channels. Don't worry about these terms right now. I'll explain them one by one. So probably let's get started. So, all right. So I have a repository already created. So this is Go concurrency constructs. I have like some code written already, and this pretty much pulls data from one URL. So it's a shopping site example. So this is Amazon's TV listing site, and I pull each TV's information. So I pull its name, its image, name, link, image, price, and reviews of each product. So I visit the products page, and for each product, I get its reviews out. So pretty much what we did with in Python. So if you're familiar with Python, you have beautiful soup. So I'm using something similar called soup in Go, though it's not as extensively built in Go. SOUP. So Python has beautiful soup. It's a pretty good scraper for Python. So just to make sure everyone's on the same page, so all Go programs start with the main function. I am taking the time. I'm storing the time now in a variable, and then. Oh yeah, sure. Much better. Awesome. So right. So this is where I'm getting the page from Amazon, downloading it. Then if it has error, I'm exiting obviously, but if it does not have error, I parse the document, and then I'm looking at the main results. Basically, I'm trying to get to each item in the page, right? So if you're familiar with HTML parsing, you'd be familiar with what we usually do, and there's nothing different over here, except I'm ranging over the results, and I'm passing them into my parse product function. That's a tongue twister. And getting it.
So your soup is basically XML parser.
Yeah, it's a XML parser. It's nothing fancy really. And in the product get reviews, I now visit the products page, and then get each of the reviews content, right? So let me just run this code in the background. So Go is a compiled language. So you usually have to do something like this to build your code, but I'm going to skip that step, and I'm going to just run it directly using Go run command.
You did start on Go.
Yeah.
So run it. I will find the main.
So So I have 3 Go files: main.go, product.go, and review.go. So what Go run? So if I give just Go run main.go, it would actually give me a compilation error because it cannot find product. So it needs to have everything, all the files provided to it.
Because it is not in the package.
It's in the same package. They are all in the same main package.
But there should be in the folder called main.
No, not necessarily. So they can be anywhere. So I have them in my root. So I've run the code. I'm passing it to JQ. So JQ is a JSON formatter. So what's happening inside my parse product function is as soon as I read the product, get its reviews, as soon as my product is ready, I'm just printing it out to std out as a JSON, just encoding it out into a JSON. So Go does all that heavy lifting for me. I'm not writing much code for that, except that this one line. So looks like it's printing out all the products and the ratings which have been given to it. So rating contains name of the reviewer, the rating which they have given, and the content of the rating, content of the review. So I have added one other formatter. I've added the time. So I was storing the time information at the start of the, and I'm basically calculating how much time this program took and how many results it has processed. So it looks like it processed 50, it took about 50 seconds to process 24 records, which is quite slow. Did you have a question?
50 seconds for what?
24 records.
Wow. That's because of the network delay.
That's because I'm visiting each product's page and then scraping its reviews, right? I guess we can do better than that, and that's what Go is designed for.
And where are you doing this? Scrolling every product page? Sorry.
So this was the product get reviews.
Oh, okay.
So that's happening within the parse product. So I'm calling once I've constructed the product, I'm just calling, hey, now get your reviews from Amazon site by visiting the products site. Fair enough, simple. I guess we can do better on this. So probably we could look at Go routines, right? So Go has this concept of Go routines, which are asynchronously run lightweight threads. These are user space threads which map to kernel threads. So these are usually lightweight than starting threads in other languages like Java or Java is the one example which comes to mind for now.
Python also has threads, right?
Yes, let's not go there.
But there are 3 ways of doing it.
Let's not. Okay, so the way I make a piece of synchronously running code concurrent is by adding the keyword Go. That's it. That's all I have to do to make it run concurrently. Let's see what the result is. Oh, it didn't print anything because what's happening is my Go routine is started in the background, and my main function exits immediately. It just prints the timing information and exits immediately. Hello, please have a seat. So I just started about 5 minutes back, so you won't be missing much context. I'm just starting to talk about Go routines. And there's no way to synchronize them. So my Go routines have been started, but there's no way of saying to my main thread that, hey, I'm running, I'm still not done with my processing. Please wait until I'm done. So Go provides us, Go standard library provides us with something called wait groups. And what it allows me to do is, whenever I start a new Go routine, so in 44 I'm starting a Go routine, which is a separate thread in its own, and I'm saying that, hey, I have added a new Go routine, and at the end of the for loop I'm saying wait for all my Go routines to be done. But I haven't provided it a way of saying that, hey, I'm actually done. So I'm going to pass my wait group within my Go routine function. So it's the parse product function which I'm passing a Go routine into. I'm going to say, hey, after I'm done printing, I just want to say I'm done. Let's see what the result looks like now. 7 seconds. So that's down from 50 seconds. It took initially about 50 seconds to download all the results for products from Amazon page. So for each product, I'm still doing the same thing. I'm still going to the product. I'm first going to the product listing page, and then going to each product's page and getting individual reviews for the product. But now, looks like it all works, right? It all works beautifully. There's one thing which I want to change though. So what's happening right now is it's kind of like a JSON stream. So each product prints out its own JSON, and then it's not really printing it out in a array, which I really want out of it. Like I want to concatenate all of my products inside the array. So let's create a variable for that. So I have my products array. So instead of encoding it out over here, I'm going to append my newly created product from my Go routine into my global products variable. And inside my inside my main function, after the wait is executed, I'll just encode the products out. That's it. Simple. Yeah, awesome. So now I should see the output in an array, right? You won't see any output until all of my Go routines are done, because now I'm waiting for all of them to complete. And looks like it took about 12 seconds, but let's not focus on the timings. That's due to network latency. That's not really due to code becoming any slower because of me appending into products. It's just network latency. So we have a flaky internet over here. So it looks like everything is appended to an array. Looks good? Fair? There is a but. So Go provides me a flag across my toolchain called race, and what it does, -race. So I'm just providing a flag -race to my go command, go run command, and it has an interesting output. So it still prints out all my 24 products, but it tells me that hey, my code looks like in your code you might have a race condition somewhere. So what's a race condition? When you are accessing shared state and modifying it independently from each other, right? In your Go routines. So this is exactly what I'm doing in my Go routines. So they are independently accessing and updating my products variable, which is a shared global variable. I can avoid this. If you're familiar with operating systems classes, you'd remember mutexes or semaphores. Probably let's try and use that. So Go's standard library provides mutexes. So I have mute sing.mutex, and okay. So one thing you'd note is I'm just defining these variables. I'm not really instantiating them. So Go has 0 values. So by default, when you say a variable and a variable name, so Go has variable name first and then the type information. So when I just provide this line, it creates an instance of the wait group and the mutex for me to start using. I don't have to do. If you're familiar with Java, new. If you're with Python, Python also has the new keyword. So I don't really have to do the new. Though Go has a new keyword, but that's for different use cases. I mean, it's still for instantiating objects and structs. Structs, not just no objects. There's no objects. All right, I'll stop blabbering and I'll add the mutex in to my code. So I'm creating a mutex in my main, initializing it, and then passing it to each of my Go routine. So what a mutex provides me is to say I'm about to do something dangerous, lock. That means all of my go routines are going to look at this lock. They are going to poll this lock to see if it's done, if it can now execute.
The next step.
Yeah. So how mutexes work internally, that I'll leave it as a exercise for the for you, but it's thread safe. It basically allows me to ensure that no race condition occurs in my code. So once my destructive task is done, like dangerous operation is done, where I'm updating shared memory with my products task, I can unblock it so that now other Go routines can do the task which they were doing. Simple, straightforward. Let's run the code again. And anytime now. That's really flaky today. 9 seconds. But no race conditions. There are no race information which Go has detected, and probably there are in tennis. Right? Okay, so looks good. But let me just take a peek at the changes which we have done. So I've imported sync library, and I'm creating a global products variable, passing weight group and mutex to my goroutine function, and then locking, unlocking, and synchronizing. So pretty much I'm writing all this code to do a simple task of synchronizing my goroutines. I guess there's a better way out there, right? So probably let's chuck all of that code out. So I have no changes in my I'm back to where I was at the beginning of the presentation. I'm just going to add the Go keyword. That's it. So we looked at weight group, we looked at mutexes. How about we look at channels? So Go provides one communication method of a construct to communicate across Go routines called channels. So there are two kinds of channels. One is the buffer channel, and there's the unbuffered channel. So the buffered channel has can take a size of n items. So you can take from 1 to n items inside your buffer channel, whereas unbuffered channel has only a size of 1, has a limit of 1. So my reading and so okay, I'll first do the example probably, right? So let me define a new channel. No, it's not.
So think of channel like data bundle. So one process can put it.
We'll look at the example. We'll just look at the example. It would become clear. So I'm passing my channel into my Go routine, and in my for loop, I'll have to again add another for loop to read from the channel inside my main function, because that's where I want to move my printing into. So I'm looping as many times as the number of Go routines I'm creating. That's all I'm doing, and I'll pass my channel into my function channel of products. So channel can take any type. You can define it on integers, strings, your own types. So I've defined it on my own product struct type. This is my type product struct, which is a struct, and I'm saying this channel will only read or write two structs. So when my product is ready, all I'm doing is I'm going to write into the channel a product. That's it. Simple. Think of it like a queue. You write one item at a time. Let's look at the output now. Seconds. But we are back to what we had before, right? Where we
What
were
was the time, sorry?
11 seconds. But I would ignore the time right now because the network is flaky. I could prove that by doing something like. So if you look at it, it kind of like doubles up the timings. It just flaky. From 100 milliseconds, it took about 300, 400 milliseconds. So it's kind of flaky over here. So I wouldn't read too much into the timings. As per my experience, I've seen the sync and mutexes code performs as good as the channels code. But there is a but. It's generally faster to write sync and mutexes code.
Generally fast to write or it executes fast?
It executes faster. They are at a low level. So channel in turn has those things inbuilt.
Have you tried channels of bigger size just to make sure that?
Bigger size as
Okay, if we have a channel of.
a buffer channel.
Yes, buffer channel.
So we could try that.
But I guess that there not be much difference.
With
why?
buffer,
Because if you write one to channel, till someone reads it right, no other go routine can write to the channel.
Sure,
So it'll
we
be
could.
wrong. You just need to give a number to them, yeah. Everything else stays the same.
Yep. So that's how you create a buffer channel, by the way. I was actually going to modify the code to instead go back to the printing of array. Let me do that as well. And I'll be printing out my products over here. But still, you can't really measure latency when your internet is lagging. Yeah. So it took about 8 seconds, but I wouldn't read too much into it.
I see it's fast.
It could be faster because of network latency. Yeah. So the point which I was trying to make was about the channels, right? So you have channels which do your synchronization mechanism for you. They allow you. They have inbuilt mutexes and synchronization mechanisms which you don't really think about. So with Kove, what the code which we had earlier versus the code which we have now looks much simpler. So what we had earlier was a lot of sync wait group mutexes and making sure that that changes. Whereas now, all that I have changed in my existing before this presentation code was that I'm writing into a channel. And then I'm constructing my products array outside and writing it into it. So I made a feature change as well as made my code faster in pretty much 8-9 lines of code of changes. So that's pretty much what I had in mind for this talk to talk about channels. Go routine. So Go's strength lies in its Go routines and its channel, the way they work, the way they interact. And so most of it comes from the CSP paper, so communicating sequential process paper by Hood. So this is the same paper which led to Erlang. So if you look at Erlang's concurrency model, it's similar to what Go has. It's just the abstractions are different. So you have channels whereas there in Erlang you have message boxes. Here you have Go routines. There you have processes, Erlang processes. One other thing is the select, which I haven't covered. I could show you a simple demo of it. It's like I have this example of select. So till now we have been reading from one single channel at a time, right? We block on a channel. We can't really read different kinds of values from a channel. Though of course you can pass in something like interface of. So this is kind of like making it generic. It's like saying I can take in any type now. I can read any type now. I wouldn't do that because that would cause a compiler panic. Instead, I would write some code which looks similar to this. So I'll walk you through the example first. So I have init function. I'm just seeding the init function. Okay, I'll start from the main function. So I'm making two channels, one of string type, the other is of integer type. And I'm looping over, I'm creating 5 Go routines. 5 is just a random number which I've chosen.
Like 5 threads.
Like, yeah, so I'm creating about 10 threads because one of type string, one writes integers into my channels. And so there are 10 threads created. Now there's this select construct. It's not same as switch case, but you could think of as a multi-way select. Like I could read from numbers if they are available, or I could read from messages if that's available, or if not, if both are not available, if there's no value in my channels, I could just print my none function. None. I could just print out none. So select.go, it prints out none, it prints out number, none. It can print out anything basically. It just depends on what my scheduler has been able to execute first and been able to write into my channel. Yeah, that. So in CSP paper, select is called the choice. And that's pretty much it. So the references for this talk were Rob Pike's Go concurrency patterns. It's a really nice talk. It talks about how you can create a search API, fault tolerant resist, which can work under 80 milliseconds search API. So it's really nice talk. I would urge you to go and look at it. Go concurrency patterns. It's a 2012 talk, which is still relevant. Go hasn't changed much since then. Wagner Mudabbai is thinking in Go. He talks about different concurrency patterns or interacting with channels. So he goes deeper into select and fan in, fan out patterns, which you can work with in Go. Tour of Go has live examples, like you can live code. You can work with live code. You can just run it on your browser. You can play around with, yeah, that's all that you could do. Go by examples has mutexes. So Go by example is a site which I really like. It does not allow you to execute the code, but it just has a collection of different pieces of code. You can just look at it and try and get a sense of how to use or how to write that piece of library which you're using, which you are interested in. So yeah, that's pretty much it. So the code is on GitHub, Chennai Golang Go concurrency constructs. Slides are on my own domain. I should change the domain name. Like I should make it shorter or something. That's pretty much it. Any questions?
There are classes in Go.
So Go does not have classes, but
They're all functions. It's a functional
no, I wouldn't. So Go has structs. So you don't have classes. You have structs. So the way you can think of it, objects without its methods, right? Having said that, Go still has receiver functions.
But they're just convenience methods.
They are convenience methods.
So instead of you passing the struct object into a function, you just put it this way so that you can call it on function over an instance.
So I'm calling product.getReviews, right? So I'm initializing my product. over here, passing it link, name, image, price, and then I'm calling the get reviews. The get reviews is basically a receiver function defined on my struct. So a receiver, so Go does not have self or this, like you have self in Python has self. This in JavaScript, you don't have all that. You just have a receiver function. You define the variable. So whatever you're calling it on, you get it as a variable. So instead of passing it like product star product, I'm defining a receiver function. That's it's kind of like a syntactic sugar. So that's how Go deals with bundling your behavior with your data.
But Go has pointers.
Oh,
Like C.
yeah. So this is a pointer. So I'm actually editing or updating the product itself. So I'm adding reviews inside my product.
So technically, I can get the self.
There's no self.
Right, technically, I can get logically because as long as I have pointed to the function, and if I pass that to the function and execute.
You mean you still access it as a variable? It's as good as passing the
That
variable.
is the self,
Yeah, it's not self. It's not implied that you are operating on this object. You have to be explicit about
Oh,
it.
yeah.
Cool.
Can it be used for multi-purpose like Java, like desktop application, web-based application?
Good question. So Go is designed as a systems programming language. It came out of Google. They have been building concurrent systems out of it, mainly for doing concurrent work, highly concurrent workloads. Go plays nicely with it. Honestly, I haven't seen a language which has such expressive constructs to just get on with building concurrent systems.
But it cannot run on a browser. It cannot run in the server.
Go 1.11, it actually introduced WASM support. So you can run Go in a browser. Yeah. So that's possible. You can run Go anywhere you want. So there is, you can run Go on your mobile. There's Go mobile project. There's Go WASM support. So WASM is WebAssembly support. So you can compile your Go code into assembly code, which can run on your browser.
But why would someone do that?
Oh, you'd do that because you'd have crypto or something like that, right? You wouldn't.
Not for web application, the usual standard ones.
It depends. There are people using JavaScript for a lot of different apps. Like for example, Slack. You could make it faster by doing WebAssembly.
The Slack speed is slower is not because of your intent.
It's not, but Slack app. I'm talking about the desktop app. It's completely built using JavaScript.
But still, I mean, the slowness is not, the latency is the problem.
We could take that. Like we could just debate over it. It's not about the latency. I'm talking about the behavior of Slack app itself, the amount of CPU it consumes and all that. So technically you can do a lot of stuff with Go app, Go code, but the places where it shines or where the open source community has adopted Go is you can look at Docker, Kubernetes. They are completely written in Go. So, yeah. Any questions?
It's more you can use it for scripting and so.
No. It's
More, see, for automation of infra-oriented activities, do people use Go or?
they do. So, what Go allows me is though I can't use it for scripting, I can. I wouldn't recommend it for scripting directly, but I would build binaries with it. So Go allows me to build something like, it's the goose flag, right?
Go as an example, yeah, what you're building.
Arch Linux. So I'm providing a flag inside my environment variable goose. It says goose is for Go operating system. I'm providing a architecture to it, Arch Linux, and I'm going to build a binary on my Mac. So this is a Mac operating system.
No, I think it is Linux slash AMD what is it you're building? Android?
I'll just quickly look up in one of my other projects. Like I don't remember the.
Actually, I mean, there are different.
Goose equals to Linux, Cgo enabled equals to 0.
Just Linux.
Yeah. So it has built a binary, Go concurrency constructs, the red one.
That is not only
That's actually architecture independent. So it can run on my system. I could just ship that binary alone. No other code is required. I can just put it on a Linux and I can run it. Very few languages have that. Rust is the only other language which I know has that linking.
show the size.
Sorry?
Show the size of the binary.
Oh, yeah. (6 MB). That's actually quite high for the amount of code I've written.
But you still always have the baggage, right? Like you need.
Yeah. So even if I'm not building it for a specific architecture, Go actually Go's binaries are heavy in nature. They are going to be about 6 MB at least.
Okay.
That's because Go embeds the scheduler code. So the magic of channels, so the magic of Go routines actually lies in its scheduler. All that code is embedded inside my binary by default. It ships with it.
I mean, when you compare this binary size with what you build as a executables for any of the operators, we take a it's like huge, very huge.
Oh, that's because they ship the entire browser inside. Yeah.
True.
All right.
Or you have VMs and VMs. This does not need a VM. Actually, Go does not need a version. Just on some bad.
Yep. All right. I'll stop the talk.